Hi, we have to count how many of each of the letters A, C, G, T there are in a given character vector or scalar. That's important here. So I've predefined this sample DNA string, and this is actually very simple. A, C, G, T. We want to compare each one of them with the entire string. So this is an outer product. So this does all combinations of elements from the left with elements from the right. This gives us this Boolean table, and all we need to know is how many ones are there in each row, so we can just reduce here. Now there is a problem, and that is if we just have a single letter, say a single C, then this outer product gives us a vector, not a matrix. And then when we sum them, then we get a single number instead of one number for all of them. So we can fix this by raveling. This forces the scalar to become a vector, and it has no effect on a vector, and that gives us the result that we wanted. So we can make this whole thing into a single tacit function like this, and it also works on our DNA string. Another way we could do this is using the key operator, but that one has the problem that things might not come out in the right order. So if we try this with the key operator, the way it works is that it returns for every element, unique element, the element as the left argument to the operand function, and then the indices on the right. So that means we can count the indices and find out how many of each there are. And we can see this is almost right, except for the ordering here. And in fact, if there weren't all the letters, then we would be missing things. So how can we fix this? Well, if we insert ACGT before our data, then we know that they will be encountered in the right order, and we know there will be at least one of each. And all we need to do then is subtract 1 from subtract 1 from the result, of course, not from with the letters. We need to get rid of those. And that gives us our right result. So here's another way that we could write this. Bonus. I actually have an idea for an extension to key such that we would be able to write this much neater. And we can import the model for this as follows. We want to get from GitHub, from my account. We want this dialog vision. And the symbol that we want the model for is quad equal. It's an operator. Okay, now let's rename that a bit to something that looks a little bit more like a symbol. And now we can try it. So the way it works is that instead of taking a function as operand, it takes a vocabulary as operand. So ACGT is our vocabulary, and then key on the DNA, and it returns the lists of indices, just like this would have returned if we didn't count them inside the operand, which means we just need to get the length of each list of indices. That would be the whole thing if key was extended like I think it should be. Thank you for watching.